Welcome to qnawire.
Okay, we're asked to search the internet and find out which esters are responsible for the smell of various uh, common smells, such as juicy fruit gum, peach, apple, and rum. And once we've found what those esters are, draw them as well as propose what carboxylic acid and alcohol could have been used to form them. So we will start with juicy fruit, which, if you look up, will be revealed to you that juicy fruit is commonly thought to come from isoamyl acetate. Isoamyl acetate. Acetate tells us that we should expect the carbonyl side to look like acetic acid, but that instead of a proton here, as we would have with acetic acid, we should expect an isoamyl. That is 1, 2, 3, 4, 5 carbons. This is isoamyl acetate, the ester responsible for the smell of juicy fruit. Now, if we want to break this down into an acid and an alcohol, retain the left-hand side, but when you reach this oxygen, instead of continuing on to an ester, just cap it off with a proton. This would be acetic acid. That's what's giving us the root name acetate, or acetic acid is the root of the name acetate and isoamyl acetate. Uh, Similarly, this isoamyl side, if we break that down into its component alcohol, should look exactly the same as the right-hand half of this molecule, except for instead of this oxygen being attached to an acetate, it will be attached to a proton as well. And that's isoamyl alcohol. So if we were to react acetic acid and isoamyl alcohol in the correct conditions, we might expect to get isoamyl acetate. So that's the first one. We could step through these remainders now. Okay, after juicy fruit, we were asked about peach. Peach flavoring is generally thought to come from benzyl acetate. So once again, we'll have the acetate core here on the left, but on the right, we'll have benzyl. That is benzene with an additional carbon. So this is benzene on the right. If we add an additional carbon to that, we have a benzyl group. Therefore, if we wanted to break this down into its component parts, we'd have, as before, acetic acid. But now we need benzyl alcohol. So we want the benzyl structure. Draw a benzene ring and attach to it a carbon, and then off of that carbon, an OH to give us an alcohol. Benzyl alcohol and acetic acid. The next scent we're asked about is apple scent. Apple scent comes from methyl butyrate. So butyrate, butanoic acid, butane, 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. We know it's a carboxylic acid. Oh, sorry. Let's draw the ester first here. And we know it's methyl butyrate, so the methyl, that tells us we can put a single carbon on the right-hand half of this ester. And if we want to break this down into butyric acid and methanol, methyl butyrate, butyric acid, methanol, simply redraw the structure with an OH on the butyric side and an OH on the methyl side. That would be butyric acid and methanol. which combined together in the right conditions would give us methyl butyrate. Our final scent is that of rum, which is commonly thought to come from ethyl propanoate or propanoate. So propanoate, that tells me propanoic acid. Propane, that prefix means 3 carbons. 1, 2, 3 carbons. Carboxylic acid, so we have a carbonyl and an OH, and it's ethyl propanoate. So actually I've gotten ahead of myself and drawn the acid, and we want the ester. It's the ethyl ester, so this should be a chain of 2 carbons. That's ethyl propanoate. And if we want to break this down into propanoic acid and ethanol, redraw the structure, but instead of an ester, we simply put a proton there. And for the alcohol side, similarly, we'll redraw the structure starting from the oxygen, but instead of the propanoate, we'll just put a proton. And we've got ethyl alcohol or ethanol.